All right, hello, geometry. Here we are with our 8.1, the Pythagorean theorem and its converse. Hopefully you are familiar with the Pythagorean theorem, so this will be a bit of review from back in algebra. All right, so the Pythagorean theorem, basically we have to have a right triangle, and that's 90 degrees. Must have this 90 degrees, or the Pythagorean theorem does not apply. Then the sum of the squares of the legs is equal to the squares of the longest side. Okay, and that's the hypotenuse. So the sum of the square of the legs is equal to the square of the longest side. Okay, and I'm going to write both of those because that's important. Longest side, which has a special name, hypotenuse. Hypotenuse. Okay, so I always like to kind of draw an arrow across from the right angle. I do that in class, so my eyes are locked in on what is the hypotenuse, and it will be the longest side, and that's because it's across from the, biggest angle. 90 degrees is going to be the biggest angle. All right, and so the Pythagorean theorem says the a squared plus b squared equals c squared. So here are some Pythagorean theorem examples. I'm just going to go through these quickly. So identify the hypotenuse, and this is going to be a more complicated diagram. So this is 6 squared plus b squared equals 10 squared. 36 plus b squared equals 100. Minus 36 minus 36. B squared is 64. And then square root, and b in algebra would be plus or minus 8, but we're just going to use 8 because it's a side of a triangle and we want it to be positive. So this is a really friendly one where you get these nice, neat whole numbers, 6, 8, 10. We're going to talk about that being a triple in just a second. So here I've got 4 squared plus 8x squared equals 9 squared. 16 plus x squared equals 81. Minus 16, x squared is 65. Square root, x is root 65. Okay, and that's fine. You get a radical. That's totally fine. It's not neat and tidy. It will not be called a triple, but it's still valid lengths of the sides of a triangle. It still works. It still encloses that triangle, and it as a right triangle. So you do want to look at 65 and see if there's anything, any square numbers that we can divide into 65. And if you just think about 65 and factor it, it's just 5 times 13. Neither one of those are perfect square numbers, so we're good to leave 65 just as is. All right, so I'm going to look at this little situation and realizing that if a 90 degree is here by the linear pair postulate, these would be supplementary, so this has to also be 90. So I'm going to put it in that teeny tiny little box there, and I'm going to work on the left triangle first. All right, so I'm going to put a y here. There's no variable there, but that does not stop me from putting one there. Why not? So 2 squared plus y squared equals 2 root 5 quantity squared. 4 plus y squared equals, so 2 root 5 squared is 2 root 5 times 2 root 5. 4 plus y squared. So outside with outside, 2 times 2. Inside with inside, that's root 25. 4 plus y squared equals 4 times 5, which is 20. All right, so moving up here, because I got a lot more problem to go, I'm going to minus the 4. Y squared is 16. Square root, and y is equal to 4. All right, so let's get y is equal to 4 right here. And then I can move to the right side of the triangle. I'm going to actually switch pen colors to help distinguish. So let's go with, again, that's going to be my hypotenuse. So now I've got 24 squared plus 4 squared equals y squared. 24 squared here is 576. Plus 16 is y squared. 592 is y squared, square root. All right, so we want to think about 592 and think about, square numbers that might divide into 592. And so let's go 592. The first perfect square number is 4. and 4 divides into there 148 times. Okay, so that's a, I'm going to have to break it down there. What about 9? Nope. What about, what's the next one? 16. Okay, and 16 I get 37. So 37 is a prime number. There's nothing else that will break down into 37. So I can think of 592 times 16 equaling to 16 times 37. So 16 times 37, and then you're going to be able to take the square part of that out. The square, the 4 is the square part of that. So this is actually going to be 4 root 37 is equal to y. And you know what? Sorry, I didn't mean to call that y. It should be x. I don't want to do the video, so just go with it, guys. I had y on my brain from here, but this is x. So x, x, x. I'll just make a note in the Edpuzzle. When I get there, I'll put a note that I'm calling it y, and I'll switch it to x in just a minute. So sorry about that. So that's 4 root 37, which is here. Okay. Whew. All right. So Pythagorean triple. Pythagorean triple is a set of whole numbers. All right. So when I say whole numbers, that whole numbers are going to be 1, 2, 3, 4, ... The whole numbers actually includes 0 also, but 0 is not going to be a side of a triangle. So really you could say the natural numbers. You could say the positive integers. That would work too. Anyway, it's just going to be not negatives and not 0. And those are going to be eligible to be part of a triple. And if they work in the Pythagorean theorem, they're called a Pythagorean triple. Basically, what this is saying is that you have no decimal or fractions or, roots. So it's not to say, this is a triple here. This still works. The Pythagorean theorem still holds. This is just not a triple because you have this root. So it's just not a special. It's not a special pair of 3 numbers that works. Okay, so these are some triples. You see these all the time, all the time, all the time. Any number, if you take 3 and multiply it by 2, and 8 multiplied by 2, and 5 multiplied by 2, that's another triple. So any multiples of these will also be triples. So that's kind of fun to think about. Anyway, so do these form a triple? You just got to throw them into the Pythagorean theorem. Well, I just wrote that one. 6 squared plus 8 squared equals 10 squared. 36 plus 64 is certainly equal to 100. So yes, this is a triple. 3 squared plus 5 squared equal to 6 squared. 9 plus 25 equal to 36. 34 is not equal to 36, so no. Yes here and no there. This one, 6 squared plus 6 root 5, all of that squared, that equal 12 squared. Do I even need to test it? Do I even need to test it? This is not an integer, so not a whole number. This is not an integer. You can call it a whole number, natural number, integer. It's not an integer. So no, I don't even need to test that it works. It might work in the Pythagorean theorem. I don't know, but I'm just, is it a triple? No, because all of these need to be nice, neat, pretty little numbers there. Let's autofill this a little bit here. Okay, so to find the third number in the Pythagorean triple, you're just going to test it out and solve. So the numbers you have are either both legs or a leg and the hypotenuse. So you have to do 2 things here. Substitute n for the legs and solve for c, or substitute n for a leg and the hypotenuse and solve for b. All right, so let's find the other triple here. These are pretty close in measurement, so I'm going to maybe just test to see that these are the legs. Let's see if these are the legs, and if I can reveal the hypotenuse. So 81 is 9 times 9, 12 times 12 is 144. That comes out to 225, and that is going to be a square number. So you're just going to go here and go square root of 225, and you see that you get 15. 15, sorry, I did that a little quickly. 15. So square root, that's an integer. That's great. So this is a triple. 9, 12, and 15. And it just so worked that that was the hypotenuse. So let's say here you wanted to try 13 squared plus 85 squared equal to c squared. And you're going to get your 13 squared, which is 169. And this is 7,225. Okay, and so, all I did there is 13 squared, 85 squared. Okay, if we add those together, we're going to get 7,394. Okay, I'm going to square root that. Second square root, 7,394 in parentheses. And this right here is not an integer. It's not a whole number, not a counting number. So sure, that worked for if this were a triangle and you had side lengths of 1385, the hypotenuse would be 85.98. But this is not a triple because this is a decimal. So this is not what we want to do here. We want to do test to find the other leg. So 13 plus b squared, and let's let 85 be over here. So this was 169 plus b squared, and this was our 7,225. Let's subtract 169 from that and go to calculator. Okay, so 7,225 minus 169 is 7,056, and let's square root that. Looking for an integer here. Whoops, 7,056. Looking for an integer here, and we get the integer of 84. So that indeed is a triple because we got that integer, that non-decimal. So this triple is 13, 84, 85. All right, backside, we're going to classify some triangles using the Pythagorean theorem. Okay, so classifying a triangle by its angles. We can use the converse of the Pythagorean theorem relation to determine whether a triangle is right. Okay, that has a 90-degree angle. Acute, those are all less than 90, or obtuse. This has one angle greater than 90. Okay, so right triangle. If the sum of the squares of the triangle is equal, all right, if the sum of the squares of the two lengths of the two sides is equal to the sum of the square of the third side, which is the hypotenuse, then you have a right triangle. So basically, this is just saying if Pythagorean theorem holds, then right triangle. That's what that's saying. If Pythagorean theorem holds, then you have a right triangle. So does the Pythagorean theorem hold here? Pythagorean theorem is not going to work if you don't have a triangle. Okay, and it is holding, so therefore this is a right triangle. Boom. All right, yes. Here, 4 squared plus 6 squared. Always put the longest side on the other side. The longest side is always the hypotenuse, so it's on the other side. 16 plus 36 equal to 49. No, 52 is not equal to 49. Therefore, not right. Okay, so that's the converse. If you want to know if you have a right triangle, just see if the Pythag holds. Okay, if you how will you know if you have an obtuse triangle? So if the square of the longest side is greater than the sum of the squares of the two other sides, the legs, the triangle is obtuse. So, you get this equality here. If you get that this is bigger over here, then that came from a bigger angle. And so that would be obtuse. If you get something smaller here, then that would become an acute. And that's what this is saying. When it's equal, you have right. When this longest side is bigger, that's obtuse. When this longest side is smaller, it's acute. All right. So right here, when you go through the Pythagorean theorem here, it's not going to tell you that you have a right triangle. It's going to tell you, you either have an acute or obtuse. So if this is greater than the sums, then you have obtuse. And similarly, if the longest side is shorter, or I guess you could say less, because we're measuring less than the triangle's acute. So here, if this is, if it equals, it's right. If this is greater, it's obtuse. If this is less, then it's acute. All right, so let's check it out. Let's do 3 Pythags and identify acute, right, or scaling, and call it a day. So 7 squared plus 9 squared. Notice I'm always putting the longest side on the other side of the equal mark. So 49 plus 81 is 121. That is 130 and 121. Okay, so if they were equal, we'd have right. But this hypotenuse, testing this hypotenuse, let's test to see if this works. This falls short. This is not equal to the hypotenuse candidate falls short. They're not equal. 130 is greater than 121, so this is acute. So this hypotenuse candidate falls short. Okay, 12 squared plus 16 squared equals 20 squared. 144 plus 256 equals 400. 400 equals 400. Ding, ding, ding. We have a right triangle. Okay, hypotenuse matched up. And last but not least, 4 squared plus 6 squared equals 8 squared. 16 plus 36 equal to 64. 52 equal to 64. They do not equal. They do not equal. This hypotenuse is, it didn't equal. 52 didn't equal 52. This is too big. Too big. So this is an obtuse triangle. All right. So that is 8.1 for you guys. So if you took the test, I hope you did well. If you're taking the test, good luck. And your assignment for Monday after testing will be the 8.2 homework in Math Excel. All right. Take care, everyone. Bye.